Hello folks, welcome to Physics 11. Let's jump right into our first video. This first chapter we are going to look at something called data analysis. It is just some of the nitty-gritty stuff that we need to learn so that we can actually get into some physics, which kind of starts like in chapter 2. So what we're looking at in this chapter is we're going to go over some math skills. We'll talk about how to use your calculator, scientific notation, some graphing, how to work with numbers. It's maybe not what you were thinking of when you signed up for Physics 11, but like I say, we are going to develop some skills that we need to have in order to actually get into some physics and have fun with that. So we're going to start by talking about what is physics. What are all of the next videos you're going to watch? So as a definition, you don't have to memorize this, but this just gives us an idea of where we're going in the next whole bunch of videos through the course. Physics is one of the many branches of science. What's really cool about physics is it deals with matter and energy and the relations between them. So matter is anything with mass. Energy, an easy way to think about that is anything that moves, because moving things have energy, but so do things that don't move even. And the relationships between them. So you can look around right now where you're sitting watching this video, and if you see things that could move or are moving, maybe there's an airplane moving out the window or cars outside, that's physics. Physics is so applicable to real life. Everything around you is physics. Just jokingly, I've put better than chemistry. Chemistry's all around us too, but quite often it's like we do a titration and maybe one chemical changes colors and we happy clap. And you walk out of the chemistry classroom and maybe you're never going to use that chemistry again. But almost every day, the stuff that you learn in a physics class, you can go out and you can apply to the real world. So I think that's super exciting. Sometimes it bugs students because they're thinking about physics when they're outside of the physics room. But I think that's great. You might as well think about the stuff you're learning, right? And be able to see it and apply it. I think that's a fantastic situation. So we're going to have lots of fun in this course. It is a really, really, really good course. And I'm glad you're here. So let's jump right into some solving equations. Let's warm up our math skills. Make sure they're still sharp. So let's start here. We've got some fractions. Ooh, fractions, they scare students. And we want to solve for x. So the first thing I would do here when you're dealing with fractions, which is not that common in Physics 11, by the way, so don't freak out. But the first thing I would do dealing with fractions is multiply by a lowest common denominator. So if it's a 4 and a 2, then we're going to multiply by 4. So a bunch of stuff here is going to get multiplied by 4. And sometimes students will stop there. But remember, the 3 is actually a 3 over 1. And so all terms in the equation need to get multiplied by 4. And then it's kind of nice here. These 4's will cancel out. Nothing to cancel here with the 1 and the 4. And then the 2 goes into that 4 2 times. So if we multiply that out, we've got 3x plus 3 times 4 is 12 equals negative 21 times 2, negative 42. Now it's nice and flat. We can shuffle that 12 over by subtracting it. It'll cancel on that side. We end up with 3x equals negative 54. And if we grab a calculator, just to make sure, negative 54 divided by 3 should be a nice number, I think. Yeah, there we go, negative 18. So there's a little warm up to get us going. Let's continue. So let's try this one. We've got kind of a rescue mission here. There's an x that's stuck in the denominator. Ooh. So let's talk about how to do that. Sometimes students want to start just like we did in the previous question. They'll say, hey, let's go and multiply by the lowest common denominator, which is x. But I maybe wouldn't do that to start. I would maybe clear out possibly this 18 shuffle it over to the other side, and that way we have just this negative 16 over x by itself. So I might start by doing this. Getting that 18 over to the other side. That's going to leave us with a negative 16 over x all by itself on the one side, which is kind of nice, equals negative 27. And now you can go and multiply both sides by x. And on that left-hand side, the x's will cancel, but on the right-hand side, they won't. So we'll be left with negative 16 equals negative 27 times x. And now we can divide both sides by negative 27. Cancel, cancel. Divide by negative 27. And that's going to give us a decimal of some kind. Let's just see what it looks like on the calculator, and then we'll chop it off at some point. It's not a huge deal. So 0.59259, let's call it 0.593 and stop there. 0.593, done. Final answer. So let's look quickly at this one. This is actually quite rare in physics, but again, it's not a bad thing to go over some of the math skills. What do we do if we've got brackets and fractions and x's on both sides? So I think the first thing I would probably do here, follow BEDMAS, let's get rid of the brackets. So I would probably distribute the 3 into the brackets and the 11 over 3 into the brackets. 3 times a quarter, remember multiplying fractions, it's going to be 3 times 1. That'll be 3/4 x plus 3 times 5 is 15 equals 11 over 3 times x is just 11 over 3x. And then minus 11 over 3 times negative 1 is negative 11 over 3. And now we can probably go ahead and multiply by lowest common denominator, which is going to be times 12. And don't forget the 15 gets that treatment as well. Every term in there gets multiplied. We can do a little reducing, like 4 goes into 12 3 times. 3 goes into 12 4 times. There as well. So we are left with 3 times 3x is 9x plus, whoa, let me check this just to make sure I don't bugger it up. 15 times 12, 180 equals 11x times 4 is 44x minus 11 times 4 is negative 44. And at this stage, we probably want to get all the x's on one side. And I'd like them to be positive, so I'm going to subtract 9x from both sides. And then just to save space and make sure I can fit this on the page, if I got I'm getting all my x's on the right-hand side, I probably want to add this 44 to the other side, just to shuffle that around. So 44x minus 9x is going to be 35x. And 180 plus 44, 224. And now we can divide both sides by 35. Grab our calculators, 224 divided by 35. Looks like 6.4. Final answer. Okay, let's try another one. This one's also got fractions and brackets, but it turns out there's something a little bit easier we can do in this one. Sometimes students will look, they'll see the 1/2 and they'll go, hey, let's start playing with like a 2. Let's start working with the lowest common denominator. But I think probably an easier option here, we've got this 1/2, you can think about that like a 0.5, and it's being multiplied by 9.8. So I would actually, I think, just start by multiplying 0.5 by 9.8. And that's going to get rid of the fraction, and then we don't have to worry about lowest common denominator. So that'll be a 4.9 times x squared plus 5. Now we want to get that x squared by itself, so we're going to want to move that 5 over with a subtraction. That is 9 equals 4.9 x squared. Divide both sides by 4.9. That's going to cancel. Let's grab our calculator for that division. 9 over 4.9. Ooh, I'm going to leave that button on my, number on my calculator, but write down a couple of decimal places. 1.837. 837. Now I don't want to use that number because it's rounded, and I have one more step here. I'm going to use the answer button on my calculator. So here we're now solving for x, and this is x squared. So to undo that, we have to square root both sides. And what's cool is I think on most calculators you can find an answer button. So here I'm going to square root second answer. You can see it's going to pull all the decimal places in my previous number there. Looks like, let's call it 1.36. So x equals 1.36. And just because this is the first time we've seen it, let's be picky and make sure that we've discussed it. Anytime you take a square root, the answer is technically plus or minus. So we've got that one there. And this one, the last one here with equation solving, we want to solve for x. It turns out when you divide, this is x times pi times 2. So when you divide, you can actually divide by the 2 and the pi all at once, which ends up working out really nicely. So there's a bit of a shortcut there. Now, you have to be a little bit careful, because if you type this in your calculator as 25 divided by 2 times pi, and make sure you're using the pi button, not just 3.14, you're going to get that answer, 39.3. And some of you watching are probably going, that's not the answer. And you're right. That is incorrect. And the reason for that is a bed mass issue. If I type this into my calculator, like you can see here as 25 divided by 2 times pi, then I have told the calculator it didn't make an error, right? It's not the calculator's error, it's operator error. I have said take 25 and divide by 2 and then multiply by pi, which is not what we want to have happen. So you have to remember, if you're going to divide by a couple of things that are being multiplied, those things have to go into brackets. So on the calculator, it's 25 divided by, open a bracket, 2 times pi, close the bracket. There's what we want, 3.98. And that's a recurring thing here in physics, a recurring issue for a lot of students, and we'll see it pop up again. Okay, moving on. Let's talk quickly about scientific notation. So scientific notation is really useful for talking about really big numbers and really small numbers. Because we don't want to write down tons of zeros on something like the mass of the planet. And we don't want to have to write a bunch of zeros after a decimal if we're talking about something tiny like the mass of an electron. So for scientific notation, I want to practice sort of putting big numbers into scientific notation and taking them out as well. So let's try this out. Let's go 4.38 times 10 to the 5. That's a big number that's in scientific notation. And I want us to try taking it out. So remember, there's actually a little game here, and I'm sure you've learned this in math at some level. There's a game that says when you have a power of 10 and it's a positive value, like positive 5, that means to expand this number, you grab your decimal point and you move it to the right 5 spots. So 1, 2, 3, 4, 5. Now what's kind of weird is we've moved it 5 times, but now I've got these blanks in here, right? That's a blank, and that's a blank, and that's a blank. And what do we fill those with? We actually just fill them with zeros. So that's going to be 4, 3, 8, and then I've got 3 zeros to add in there. 1, 2, 3. So that number is 438,000. Now let's go the other way. let me give you a big number and let's put it into scientific notation. So let's go 2960. So it's not huge, but it doesn't really matter. Let's put it into scientific notation anyway. In this case, we typically want the decimal for scientific notation to go between the first and the second digit. So we want the decimal right there. Currently, the decimal is sitting over here. So now we're going to drag it to the left until we get it in between the 2 and the 9. And we're going to keep track of how many sort of spots that takes. Oops, sorry, I touched the screen there. So that is 1, 2, 3 moves to get it between the 2 and the 9. So we're going to write this as 2.96. I don't really need to worry about putting the zeros in there. And that's times 10 to the, we moved 3 spots, so 10 to the 3. So that's working with big numbers. Let's look at a couple of small numbers. So let's switch gears a little bit. Let's go 1.52 times 10 to the negative 4. So what about a negative exponent on the power of 10? Well, that means we're looking at something smaller than 1. We're looking at a really, really small number. So when you see a negative power of 10, that tells you to grab your decimal point and not move to the right, but move to the left that many spots. So in this case, 1, 2, 3, 4. And again, it's kind of weird. We've got some blanks in here. What do we fill blanks with? We fill them with zeros. So that's going to be 0 decimal. Now I have 3 zeros to put in after the decimal. 1, 2, 3. And then I can tack in my 152. And you can see that's a nice small number. And let me give you a small number and let's put it into scientific notation. Let's go 0.0000911. So we know we're going to have a negative exponent or a negative power of 10. We're going to grab that decimal point and we want to jam it between the 9 and the 1. Again, sort of between the first and second digit, not counting zeros. So that takes 1, 2, 3, 4, 5 moves to get there. So that's going to be 9.11 times 10 to the not positive 5, this is a small number, times 10 to the negative 5. So the next thing I want to show you, now that we know how to put numbers into scientific notation and take them out, is how do we do this on the calculator? And you may remember some exponent laws that you learned in math class, and you don't need to remember those for physics. Woohoo! We are going to trust the calculator. So let me show you how to type scientific notation into your calculator. That's going to be this drill here. So I'm going to show you on my graphing calculator. There could be another button that you might need to use. If you get stuck with your calculator, please come and find me or email me and I'll help you out. But on this calculator, you don't need brackets, actually on any calculator. I only have the brackets in here so that we can see the numbers separate from each other. One of the types of buttons you're looking for is this one here. Hopefully you can see that. It's a double E. That means times 10 to the power of. So I type it in as 2.4, second function EE. That says 2.4 times 10 to the power of, and I type in a 6. You never need to type times 10 on any calculator, so you'll never actually do that. You'll have a magic button that does it for you. In this case, I'm just going to finish this off and I'll show you what one other button could be. So 2.4 exponent 6 times 7.5, second function EE, 8. And then you bang enter, and that's the number you're looking for. 1.8 times 10 to the 15. So you're looking for, on your calculator, an EE. Some of you might have, I bet the other one that's going to be really common is an EXP button. So you can also look for that. That will be your scientific notation button. And quite often you'll be typing a number into your calculator, something like 1.96, and then when you type the little EXP button, you'll see some little zeros show up there. and that is saying times 10 to the power of, and then you can go and type those in. Here's what you don't want to use. You don't want to use on something like this graphing calculator. You'll see that there's a 10 to the x button. That is not the one that you want. Okay, so don't use that one. I'm going to guess it's probably a double E or an EXP. Again, if you can't find one of those buttons, get in touch with me and I'll help you out. So let's try another couple just to make sure this works. What about if you do a division? Well, you simply type those into your calculator. So 6.5 times 10 to the power of 18 divided by 4.9 times 10 to the power of 11. Oh no, look at that. Sometimes you get unlucky and you get a big number that you then have to put into scientific notation. Your calculator won't always put big numbers into scientific notation for you. So if you get a number like this on your calculator, we now have to play the game where we just count how many times we're moving that decimal point. So that's going to be 1, 2, 3, 4, 5, 6, 7. So that looks like a 1.33 times 10 to the 7. So something like that for your final answer on that guy. And then what about this one, where you've got scientific notation, but then also an exponent? So there's actually another button to use for regular old exponents, like this one, the 3. You're going to look for, on a Texas Instruments calculator, a hat button. Or if you don't have a graphing calculator, you might have, I think it's an x to the y, but it could be a y to the x. I can't remember which one it is. So one of those buttons will be your, I'll say or, will be your regular exponent button. So on a graphing calculator, 4.3 times 10 to the power of 2, and I don't need brackets. I don't think your calculator will either, but I want to take that number and cube it. So to the power of, there's my hat button, 3 divided by 3.4 times 10 to the power of, remember, don't type times 10, find that magic button, the double E or the EXP, and now we want a -8, so use your negative button. There's the number, 2.34-ish times 10 to the 15. So again, please get in touch with me if you need some help with your calculator, because once you figure it out, you're gold. Now quickly, the last thing I want to go over is conversion factors. This is something you're going to spend a whole bunch of time doing in chemistry class. You'll do this almost every day in chemistry class, to be honest. So I want to show you just how these conversion factors work very quickly. It's really just like switching between units. And you've done that in math class, like going from centimeters to meters or meters to kilometers. But we might just up the ante slightly with more than one conversion. So I've given you a couple statements here, and we're going to say those statements are true. And then physicists like to measure stuff. That's one of the things that we really, really like to do. We measure things about the world around us. So maybe you're walking by some kids' pool. Some kids have filled up one of those big, little plastic pools from Walmart. And you wonder, hey, there's about 4.6 gallons of water in there. How many molecules would that be? So in order to get from gallons into molecules, we know here we're starting with gallons. And now what we're going to do is we're going to play this game where we use fractions. So 4.6 gallons, and then I'm going to multiply by some fraction. And with this fraction, my only goal is to cancel out the units of gallons. So what I have to do, I know I want to get away from gallons and eventually into molecules. But I go back up to my 3 little statements here. They're showing things that are equal. And I want to find one with gallons. There it is there, the bottom one. It says that 1 gallon is equal to 3.78 liters. And since we want to cancel the gallons, I need to put gallons on the bottom of my fraction. So 1 gallon. The fraction bar is like an equal sign. So 1 gallon is equal to 3.78 liters. And that's a great way to set up that question so far, because with gallons on the top and the bottom, I can cancel them out. Now you don't want to stop there because you'd be left with just liters. And that's not what we're looking for. We want molecules. That's our end goal. So what we can do is we can scratch out the conversion factor we just used, because you don't want to use it again. You only want to use each of them once. And now our goal is to get rid of the liters. So we're going to multiply by another little fraction, but this time we want to cancel liters. So we can go with that one. It says we want liters on the bottom so that we can cancel with liters on the top. It says that 1 liter of water is equal to 1,000 grams. And that's great because liters top and bottom means we can get rid of those units. And we can get rid of that conversion factor. We've used it up. But we don't want to stop quite yet because we're left with units of grams. And that's not what we want. We want molecules. So now I'm just going to get rid of grams. That's my goal. And we know if grams are on the top, then they're going to have to go on the bottom. And hey, that last statement says 2.98 times 10 to the negative 23. Sorry, I got to squeeze this in here. Grams is equal to 1 molecule. Sorry, that looks like mole, but it should be molecule. I can't fit it all in there. And that's great because grams top and bottom means we can cancel them out. And hey, look at that. We're left with molecules. There we go. So now the question might be, well, what the heck does that look like on the calculator? And it turns out it's pretty darn easy. You grab your calculator and you're going to multiply by all of the numbers on the top. So the 3.78 and the 1,000. And then we're going to divide by all the numbers on the bottom, like the 2.98 times 10 to the negative 23. So it's 4.6 times 3.78 times 1,000 divided by 2.98 times 10 to the power of negative 23. And we get that number. 5.83 times 10 to the 26. 583 times 10 to the 26. And that will be molecules. So let's try one more question here. We're going to convert 18 kilometers per hour into meters per second, something we have to do in physics a lot. So what we need to do here is actually convert a couple of different units. So we need to get kilometers into meters and hours into seconds. So we're starting with 18 kilometers per hour, and you want to stack that fraction up and down. And now we're going to play that game where we multiply by some fractions. So you've got the choice here. You can convert kilometers into meters first or hours into seconds. It really doesn't matter. And I might go kilometers into meters because that's an easy one. So kilometers on the top means we need kilometers on the bottom. And from math class, you probably remember that 1 kilometer is equal to 1,000 meters. And that works great to stack our fraction that way because kilometers top, kilometers bottom cancel out. And that leaves us with meters per hour, which is not what we want. We want meters per second. So now we're going to work at canceling out the hours. We're going to get that into seconds eventually. So hours on the bottom means my next fraction is going to have hours on the top. We know that 1 hour is equal to 60 minutes. And that works great because hours on the top cancel with hours on the bottom. But we don't want to stop there because that would leave us with meters per minute, which is kind of weird. So let's do one more conversion. Minutes on the bottom means we're going to want to cancel with minutes on the top. And we know that 1 minute is 60 seconds. Minutes will cancel out. And if you look, we're left with meters on top of seconds, which is exactly what we want. So now we grab our calculator, type in your initial amount, which was 18 kilometers per hour. We multiply by 1,000. And then we have to divide by 60, not once, but twice. So here's my recommendation. You actually can't type it like that. You're going to get the wrong answer if you do it that way. That's a bed mass issue. It is not 18,000. What I want you to do, my recommendation, is it's 18 times 1,000, and then you divide by 60 once, and you divide by 60 twice. So every time you see a number on the bottom that you're dividing by, that is a separate division. When you type that in your calculator, there's the magic answer, 5. So that's equal to 5 meters per second. So what I want you to try with this lesson is worksheet 1. Should be able to do all of it. It is sitting in the All Resources folder on the Physics 11 website. Maybe let me pull up the website just so you can see what it looks like, and I'll quickly show you where that is. So hopefully you can see this. That is the address for the Physics 11 website. I guess if you're watching this video, actually you're on the website. So it's all good, you're there. But if you go to the Physics 11 page, oh, Mr. Heinrich, you will find a little folder at the top. This is an old computer I'm using, and this may not work. But there is a little folder on the top called All Resources, and you will find worksheet number 1 in that folder. So I'll give up on the website. Sorry, computer is getting angry. Here's what worksheet 1 looks like. So you can find this document in that folder. Try it out. The answers are also in that folder. They're called, oh, there we go. See, angry. Chapter 1 Solutions, I think it's called, or Chapter 1 Answers. So you can always check your answers there. And if you get stuck with any of that, feel free to come on in and ask for help or fire me an email. Happy practicing.